Welcome to the deep dive. So if you thought the holidays meant a bit of a slowdown in cloud infrastructure releases, well, think again. We are walking into the new year with, a truly dizzying stack of announcements from AWS. I think we counted almost 50. And these all rolled out in that short window between, December 22nd and January 9th. This wasn't some big reInvent keynote, but the sheer volume means there are some critical performance bumps and operational tweaks in there that we absolutely cannot miss.
It's like a massive pipeline flush, When you see 49 releases in just a couple of weeks, our mission here isn't to just list them all out. For you, the technically proficient listener, our job is to filter all that noise. We need to deliver the core technical themes that are going to define your work, probably for the first quarter. And we're seeing three big ones. First, massive generational improvements in core compute. Second, a new level of really granular operational observability. And third, the rapid, very focused expansion of agentic AI services. So we're here to give you the technical so what.
Okay, let's unpack this. We should probably start where the rubber meets the road. Core compute, storage, and infrastructure scaling. This is where all the raw horsepower updates live, and it seems to be driven largely by the new Intel Xeon 6 rollout.
Yeah, and this isn't just a minor iteration. It's a clear generational leap, and AWS is aggressively rolling it out regionally now. It's hitting their foundational instance families, R8i for memory optimized, M8i for general purpose, and C8i for compute optimized. We saw immediate expansion into key regions like Mumbai and Paris.
The benchmarks that AWS is publishing across all three of those families, R8i, M8i, and C8i, they're pretty eye-catching. What are the common technical benefits that you zeroed in on?
Well, the synthesis really points to two things: efficiency and speed. AWS is saying you're getting up to 15% better price performance compared to the last Intel-based generation. And on top of that, 2.5 times more memory bandwidth. So if you're currently running on, say, R7i, M7i, or C7i instances, the general performance ceiling is just raised by a flat 20%.
That 20% general jump is compelling for most workloads, but I'm guessing those custom Xeon 6 processors are really tuned for specific heavy lifting tasks.
They absolutely are. When you start looking at the application level gains, the numbers get serious. We're talking up to 60% faster for NGI and XWhip applications.
60%.
Yeah. And 30% faster for PostgreSQL databases. And, crucially for the AI crowd, up to 40% faster if you're running deep learning recommendation models. That kind of application-specific gain is what drives real-world business decisions on whether to migrate.
I also noticed they're heavily promoting the Flex variants, the R8i Flex and C8i Flex. It almost feels like they're saying don't jump straight to the standard instances.
That's the key operational insight right there. The Flex variants are being positioned as the recommended default choice. For the vast majority of users, workloads that don't continuously demand 90-100% CPU, they cover all the common sizes up to 16x large, the standard R8i, M8i, and C8i instances. They're now for continuous high CPU usage, or if you need that brand new 96x large size for the absolute largest SAP-certified applications.
So it's a clear signal to right-size your initial choice.
Exactly.
Okay, moving from general compute to those specialized I/O-intensive scenarios. We saw the storage-optimized i7i instances expand regionally. These are the workhorses for high-density, low-latency data apps running on 5th-gen Intel Xeons.
The i7i is the low-latency storage beast. Compared to the previous i3N, you're getting 40% better compute performance and 20% better price performance. But the technical punchline is really the storage layer. The third-generation AWS Nitro SSDs deliver up to 65% better real-time storage performance.
Help us translate that. What does 65% better real-time storage performance mean in practice for someone listening?
It means lower latency variability. It's about consistency. So if you're running complex high-transaction databases or maybe real-time analytics that need fast, consistent access to massive local NVMe datasets, we're talking up to 120 terabytes of density. That 65% bump ensures your database queries that might occasionally spike to 2 seconds are now consistently executed in milliseconds. That consistency fundamentally changes the user experience.
That's significant. Okay, let's shift gears completely from the raw metal to the execution environments. What did we see in serverless and containers?
The big news for developers is really about support and simplicity. AWS Lambda now supports .NET 10, which is an LTS release supported until 2028. This update brings access to all the latest platform features, and importantly, it supports Lambda managed instances. So you can run Lambda on EC2, but keep that serverless operational simplicity, which often means better cost efficiency for steady state workloads.
And for container orchestration, Amazon ECS brought support for TAMFs, mounts to Fargate, and ECS managed instances, which extends it beyond just EC2, right?
Yes, and this is a fantastic technical win for both security and performance. A TMFS is basically a temporary memory-backed file system right inside the container. It's perfect for fast scratch files or caches because the data is ephemeral. It just disappears when the task starts. The critical win here is that it allows your container to use the read-only root file system setting,
Which is a major security hardening practice.
Exactly, but you can still let the application write to a fast temporary in-memory directory.
It's a great feature, but isn't relying on in-memory storage a potential headache?
Yeah.
I mean, for debugging or forensic analysis, if a container fails, you lose all that volatile state instantly.
That's the trade-off. You've hit the nail on the head. It's a performance and security win, but it absolutely requires mature logging and monitoring to capture state before a failure, because you won't be able to inspect the failed container's scratch space after the fact. It forces better discipline. Oh, and before we move on, we should quickly mention the Amazon MQ Rabbit MQ enhancements.
Right, the new authentication.
Yeah, for 4.2 plus brokers. Support for certificate-based MTLS and external HTTP-based authentication. That's a huge step toward integrating RabbitMQ into existing complex enterprise identity systems.
Excellent point. Okay, zooming out from the raw infrastructure layer, let's look at what we're actually running on that metal. The intelligence layer AI, agentic workflows, and data visibility.
The focus here is definitely shifting. It's less about just having the biggest model and more about having the most efficient model for tooling and for agency. Amazon Bedrock now supports the NVIDIA Nematron 3 Nano 30B A3B model.
So what makes Nematron 3 Nano specifically suited for this next generation of app development?
It uses a hybrid mixture of experts, or MOE architecture.
Oh, you okay?
Yeah, and the short version of MOE is that instead of activating the entire massive model for every single request, it only activates the few expert parts that are necessary for that specific task. This sparsity leads to much higher throughput, which is especially crucial for things like coding assistance and complex agentic workloads, and it does it without sacrificing reasoning capability. It also has a massive 256K context window.
And what's making that perform reliably on Bedrock? Is there something new under the hood?
That's Project Mantle. It's a new distributed inference engine, and it's purpose-built for high-throughput, reliable serverless inference. It makes sure that this MOE model can scale reliably and maintain OpenAI API compatibility right out of the box. We also saw Minimax M2, another MOE model, this one with 230 billion total parameters, arrive on SageMaker Jumpstart, also clearly aimed at those high-performance agentic tasks.
And tying into the dedicated AI compute side of things, the AWS Neuron SDK 2.27.0 release.
This is critical for users who are really dedicated to AWS's own AI hardware. The highlight isn't just the Trainium 3 Ultra server support, but the private beta launch of native PyTorch support via Torch Neuron.
Data support, so no wrappers.
Exactly. It means developers can use standard PyTorch frameworks without modification, running directly on Trainium hardware. They're finally prioritizing that developer experience to simplify leveraging their specialized silicon.
That simplification theme really carries over to the workflow side, especially with Amazon Quick. It seems to be expanding its role from a search tool to a full-on AI-powered agentic teammate.
Quick's real significance lies in unification and action. Its integration now expands to third-party agents from Box, Canva, and PagerDuty, alongside built-in actions for tools like GitHub and Linear. This means a user can just tell Quick, find the relevant document in Box, summarize it for me, and then create a PagerDuty ticket if these conditions are met.
So it's basically eliminating the cognitive load of constantly context switching between all these different SaaS apps. It just makes them all callable from one interface.
Precisely. It achieves this using something called the Model Context Protocol, or MCP, and standard OpenAPI connectors. It's the operational glue that binds all these specialized services together, making the AI useful beyond just generating text.
On the customer service front, Amazon Connect continues to enhance its automation, now supporting more complex data structures within contact flows.
Yes. This is a huge technical improvement for anyone designing flows. Connect can now natively store and work with nested JSON objects and loop through arrays. So instead of making 10 separate API calls to get 10 open customer orders, you retrieve them all in one request and then just loop through that array within the flow to present options to the caller. It drastically cleans up complex workflows.
And finally, a great little piece of administrative friction reduction. AWS End User Messaging SMS launched a generative AI registration reviewer preview.
That's a perfect example of targeted operational AI. I mean, dealing with mobile carrier approvals for SMS messaging can be so iterative and frustrating, right? This reviewer provides immediate smart feedback on your registration forms. It checks the message sample, the use case, compliance factors to significantly increase the likelihood that the carriers accept it correctly the first time. It turns a manual, opaque process into an automated, guided one.
Let's move to our final necessary pillar: data, observability, and operational governance. The trend here seems to be pushing cost tracking and visibility down to the most granular level possible.
The clearest example, and one that operational teams will absolutely appreciate, is Amazon EMR Serverless adding support for job run level cost allocation. Historically, your cost visibility just stopped at the application level, which can span multiple business units or workloads.
Okay, so does this mean we can finally split those EMR costs cleanly between internal business units, say between finance and marketing, even when they're running jobs on the same application cluster?
You absolutely can. By assigning cost allocation tags to individual job runs, you gain that domain-specific cost tracking within a single EMR application. This allows for incredibly precise benchmarking, chargebacks, and optimization, drilling right down to a single job execution's cost footprint.
We saw similar granularity enhancements in EC2 Capacity Manager with the new spot interruption metrics.
This is a critical observability feature for anyone running large-scale, cost-optimized environments. EC2 Capacity Manager now exposes 3 new metrics: spot total count, spot total interruptions, and the resulting spot interruption rate. This data lets technical teams identify historical patterns, compare capacity pools across different AZs or regions, and just make much more data-driven decisions to optimize their spot instance strategy for higher availability.
And staying with observability, AWS Clean Rooms added detailed monitoring for collaboration queries.
This is all about demystifying the black box. It publishes detailed SQL query performance and resource utilization metrics directly to CloudWatch. So if you're a creator or an analysis runner in a clean room, this helps you pinpoint exactly where resources are being spent and troubleshoot performance issues for complex workloads like, say, campaign lift analysis.
On the database and analytics front, Amazon Redshift announced 4 new features for materialized views on data shares. What's the most impactful capability here for resilience?
The biggest technical change, I think, is the support for concurrency scaling of the create materialized view DDL command. So if creating that view requires intense resources, Redshift can now automatically scale the cluster resources just to handle the creation process. This is vital for maintaining predictable SLAs, especially for mission-critical analytics apps where a slow MV creation could block other processes.
We also saw some key managed service scaling and regional distribution announcements that often get overlooked.
Right. Amazon Lightsail now offers much larger managed database bundles up to 8 vCPUs and 32 gigs of memory, which addresses a major scale limitation for customers who really prioritize Lightsail's simplicity. And speaking of distribution, Amazon RDS for SQL Server added cross-region read replicas in 16 additional regions.
Wow, 16.
Yeah, that's a huge boost for global latency reduction and for simplifying disaster recovery for SQL Server users, particularly those needing replicas closer to their user base. We also saw Oracle Database at AWS expand into US East 2, EU Central 1, and AP Northeast 1, which directly helps European and Japanese customers with specific data residency requirements.
Let's wrap up with governance and automation tools. AWS Config and Secrets Manager both got some key governance improvements.
AWS Config dramatically increased its coverage. It added support for 21 new resource types across major services like EC2, SageMaker, and S3 tables. If your goal is full centralized auditing and automated remediation, that increased coverage is crucial. Meanwhile, Secrets Manager improved management by supporting enhanced secret sorting in the console and the API. It's a minor change that greatly improves the operational management when you have thousands of secrets.
And finally, 2 great administrative automation tools: AWS Wicker's new admin APIs and AWS Transform for VMware.
The Wicker admin APIs are essential for large-scale security management. They enable programmatic network management. This means administrators can automate the user lifecycle like auto-creating users based on directory attributes and enforce standardized network and security policies via code. It integrates secure comms administration right into existing identity pipelines.
And AWS Transform for VMware is making hybrid cloud migration easier with its new automatic network conversion.
This eliminates a massive amount of manual, painstaking effort. AWS Transform now analyzes VLANs and IP ranges from the source data center, and this covers both VMware and non-VMware workloads. And it automatically maps and provisions the corresponding AWS networking constructs like VPCs, subnets, and security groups, all via infrastructure as code.
So it just cuts weeks out of the planning phase.
Exactly, weeks out of the network planning and mapping phase of a large-scale migration.
This has truly been a deep dive into updates that are really focusing on the fundamentals, ensuring better performance and visibility.
It absolutely has. This whole wave of updates emphasizes operational control and automated scaling at a granularity we haven't really seen before, from tracking costs for a single EMR job run all the way to that request-level observability in ECS.
And overlaying that foundational strength is this clear, accelerating path toward intelligent automation. The rapid rollout of high-performance instances like the Xeon 6 R8i family, alongside dedicated, efficient AI models like Neutron 3 Nano and these powerful agentic tools like Amazon Quick, it really defines the current development cycle.
Indeed. Which leads to a final provocative thought for you to consider. The shift toward agentic capabilities is becoming less about the raw power of the underlying model and far more about the integration layer. So how fundamentally does a tool like Amazon Quick, by handling all that context switching and those third-party actions from Box and PagerDuty, how does that change the operational requirements for building complex cross-platform workflows within your own organization? Do you need fewer custom integrations if Quick can act as the central orchestrator, something to mull over as you start the new quarter?